Zener diode characteristics. Zener diode, it's a special kind of diode which is usually preferred to work in its breakdown region. That means it maintains a constant voltage. If any change in the voltage occurs, then it maintains the constant voltage by varying the current. Here we can see the circuit construction to study the characteristics of a zener diode. So it's also a hardware experiment, and here it's a RPS, means we just need to analyze the characteristics of zener diode, how it works in the forward bias and reverse bias. So let's initially first see about the forward bias condition of zener diode. Forward bias means this is a negative and this is positive. This positive has to be connected to the positive side and negative to the negative side. This is now forward biased. So in forward biased, we need to measure the voltage across the zener diode and the current through the zener diode. So I am connecting one voltmeter across the zener diode and one ammeter through the zener diode to measure the current flowing through it. Okay, that is the forward bias characteristics. If we see the graph of this, then we can see this is the graph in the forward regions, and we can see that it's similar to the normal diode. That means its cutoff is around 0.7 voltage, you can see. Okay, then then let's see its reverse characteristics. How to see the reverse bias characteristics? Just you need to replace, no, not replace, just you need to reverse the polarity. That's it. Okay. No, sorry. To reverse the polarity. So, okay, I will reverse. Yeah, I will reverse. That's it. You need to connect it properly. Yes. Now it is the reverse bias characteristics. When we see the waveforms in the reverse bias characteristics, we can observe like this. Okay, this is the breakdown voltage. It's around oh no, here it's a scale is huge. We'll get the waveforms like this. The main thing in the practical is that we need to measure 4 types of resistances. That means the static forward resistance, dynamic forward resistance, static reverse resistance, and dynamic reverse resistance. So how to measure these things? Static and dynamic. Okay, static means something like a constant, dynamic means varying. If you want to measure the static forward resistance, after getting the graph, that means we need to plot the graph on a graph sheet. Then after getting the graph, to measure the static forward resistance, here we can see this is a forward bias graph. So at this the current increased, okay, at this point, and here you need to plot means we need to take one point, any point like this, then just plot on I. So we know that V equals to IR and R equals to V by I. So here we are getting some voltages divided by this I. That gives the static forward resistance. For dynamic means we need to consider some small range in that graph. It means I will plot like from here to here I will take, okay, this is a delta V, and from here to here this portion is delta I, okay, this is a delta I. Then if we take the delta V by delta I, that is the dynamic forward resistance. Same way we need to measure in the reverse characteristics also by taking the graph like this. For measuring the dynamic we need to consider like this, and from here to here, from here to here, this region is the delta I and this is the delta V by delta I. That will give the reverse dynamic, and for reverse static we need to consider a single point like this, yeah, this one, and from this point and this point, that's a static. For dynamic we need to consider a small range. That's it in characteristics of a zener diode. And then comes the load regulation and the line regulation. Load regulation, what is this? No, first we will see about line regulation. What is this line regulation? Line regulation means we are regulating the line, that means we are regulating this power supply. So in this line and the load regulation, this is especially we are doing in the zener diode reverse bias condition, because zener diode is made to work in the reverse bias itself. So for line and the load regulation we are taking this zener diode in a reverse bias condition. So now this is in a reverse bias, or we can just for a simplicity we can consider like this, okay. Then for a line regulation means this has to be RPS, because we need to change the voltage of the line, and here one load has to be there. Let's say this is my load, okay. I'm not changing the load is constant. Yeah, here the load is constant, it's 1k. We are not going to change the load, but we are changing this RPS voltage, that means from 1 volt, 2 volts, 3 volt, 4 volts, and we are measuring how much is the, it's a line regulation, no, so we need to measure how much is the voltage, load voltage, and current. Current is not necessary, because zener diode means especially it's used to uh, constant the voltage has to be constant. So if we change the RPS voltage, we can observe that the voltage across this zener diode or this load, that has to be constant, that is the line regulation. Then in load regulation means the name itself says the line is constant. That means here instead of RPS we are taking a constant voltage. This is constant. In load regulation we are not going to change the power supply, and here we are taking one this has to be changed, that means from 1 kilo ohms to 2 kilo ohm, 3 kilo ohm, like that we need to change this load, that is the load regulation. if we change the load also, this